Okay, so volume, we already talked about a little bit, is how much fits inside of a three-dimensional object, right? Space inside. That's measured in cubic units, always cubic units for volume. Surface area is the total area of all the surfaces added together. Any type of area is measured in square units. Okay, a pyramid, which we've been looking at, is a polyhedron that has one base, and then all of the lateral faces are triangles. So if you look down here at this diagram, you can see each lateral face is a triangle. Okay, a couple important things about pyramids. It's named for the shape of its base. So, for example, this first pyramid pictured here is a square pyramid because the base is a square. This one is a hexagonal pyramid because the base is a hexagon. You could pretty much make a pyramid out of any polygon. You just gotta put a point to the top and connect them, right? So we are going to be only dealing with regular pyramids, meaning anytime you see a diagram of a three-dimensional pyramid, you can assume all of the sides are the same length. Okay, they're always a regular pyramid for our purposes. Okay, the height of a pyramid is just like when we found height of two-dimensional objects. The height is always perpendicular to the base. Okay, so the altitude and the height, the altitude is the segment that you draw from the vertex in a pyramid straight down perpendicular to the base. Since we're only dealing with regular pyramids, that's always going to hit at the exact middle of that polygon base. Okay? The length of the altitude is just the height. So let's just add here that it's perpendicular, right? So perpendicular to the base. Okay, so there's two different types of height that are important in pyramids. There's something called the slant height, which is represented by the script lowercase l. If you add that into that little blank there. The slant height is the height that goes up the side of the pyramid, the slanty side. Contrasted with the height, which comes straight down and is perpendicular to the base. So you've got a slant height and a height. Now, the key to finding surface area and volume in pyramids and cones actually is if you connect that height to the slant height, it creates a right triangle. And so there's these hidden right triangles that we're going to need to find surface area and volume of pyramids. Okay, I'm going to pause the video for a second just to show you something visually. Okay, so we can see we can pull out that triangle in all of these pyramids. I highlighted them here. This is the height, slant height, apothem. Height, slant height, apothem. So if you redraw the triangle outside of the pyramid, anytime you have a pyramid, remember that the height of the pyramid is the height of this triangle. The hypotenuse of the triangle is the slant height of the pyramid, and then the base there is the apothem. Okay, in cones, you have the same situation. There's a hidden triangle inside a cone. There's one difference The height is the height. The slant height is the hypotenuse. In a circle, what would you call this bottom piece? Radius. So this time it is the radius. With other polygons, it's going to be the apothem. Okay, we know the base of a cone is a circle. Slant height again is lowercase l if you want to fill that little blank in there. Now, I put a big star here because this is the list. You're going to hear me talk about the list a lot. Okay? I'm going to say make your list. This is what I'm talking about. You'll understand better once we actually do a surface area and volume problem. But the surface area and volume, two different formulas, but they both use a lot of the same values. So instead of calculating all these values once for surface area and then again for volume, we make the list. Once you have your list filled out, everything you need for both formulas is there, ready for you to use whenever you need it. Okay? So, let's go through what these letters stand for. Capital B. Capital B stands for the area of the base. When I ask you what does the capital B stand for, don't tell me base. It's not just base. It's the area of the base. Okay, so capital B is the area of the base. It's capital because it's more than just one value, right? It's the calculation. You got to actually calculate the area of the base. Okay, H is the height of the prism. Now, I choose to make my height of the prism a capital H to distinguish it from the lowercase h's that are in your area formulas, right? Like triangle is 1/2 BH, right? This is a different H. This is the height of the entire prism, that thing that we said is perpendicular to the base. Okay, P stands for perimeter. P always stands for perimeter. Remember that if it's a cone or a cylinder eventually, the base is a circle. And what do we call the perimeter of a circle? Circumference. So that P is going to turn into a C when it's circular. C stands for circumference. Okay, lowercase script l is a slant height. Notice, since there's that right triangle that we pull out, these hidden right triangles, those triangles, they'll give us two sides sometimes, and we have to find the third side based on the Pythagorean theorem. Okay, so let's get to the formulas. The formulas for volume, pyramids and cones, basically same formula. Like I mentioned before, it's going to be base times height, area of the base times the height of the prism, all divided by 3. Anything that's pointy comes to a point. It's going to be divided by 3 for volume. All right. Surface area. Surface area is 1/2 PL plus capital B. 1/2 perimeter times slant height plus the area of the base. Cones, same basic formula, but the P becomes a C, right? 1/2 CL plus B. Okay, so we talked about capital B means the area of the base. Think about the implications of that, though. If I said, what's the formula for capital B? What would you need to know? What's capital B stand for? Okay, so how do we find the area of the base? Cooper? Okay, so if it's a hexagon, capital B is going to be area of a hexagon. Right? If it's a hexagonal pyramid, capital B is going to be 1/2 AP, because that's the formula for the area of a hexagon. What if it's a cone? Capital B is what? Area of a circle, which is pi r squared. What if it's a square pyramid? Capital B is the area of a square, which is just length times width, or base times height, right? So that capital B is a different formula every time. Depends on what the shape of the base is. All right, C always stands for circumference. Okay, remember that's 2 pi r. And then capital B with cones is always pi r squared, right? Capital B in general matches the base, but with cones, it's always a circle, so pi r squared. Notice this box that says, or SA equals pi r L plus pi r squared. That's another way to write the same exact formula. 1/2 CL. Well, if I take 1/2 and I plug in 2 pi r, 1/2 times 2 pi r for C times L, plus, and I plug in pi r squared for B. When you do 1/2 times 2, what happens? They cancel out, and this is what I'm left with. Pi r L plus pi r squared. So it's the same formula. You're just plugging in for the C and the B. That comes in handy sometimes, and we'll do it in the future, but when they want you to solve for the radius or something, then you need the formula that has the r in it. Okay, so if you look at the net again of this pyramid, and then compare it to our formula, 1/2 PL plus capital B. Which part of this is the capital B? The hexagon, right? So 1/2 PL is the rest. So this formula is basically 1/2 PL gets you all of these triangular faces. 1/2 PL gets you the faces all added together. And then the plus B adds on the base at the bottom, right? So 1/2 PL is what they call the lateral area. It's all the faces except the base. And then plus B makes it the full surface area. To actually approach one of these problems now, like I said, I want you to start with your list. So, I started the list here for you. P, L, B, and H, doesn't matter what order it goes in, but remember it's all about the base. P is the perimeter of the base, okay? Capital B is the area of the base, right? Height is the distance from the vertex to the base, okay? It's all about the base. Perimeter, first we're going to name the pyramid. Remember, the pyramid's named for the shape of the base. What shape is this base? It's a square. Sometimes it's helpful to redraw the base as a two-dimensional shape to help you, get it right. I told you we're always going to be using regular polygons, so if this is 40, then this has to be 40 also. So, what is the perimeter? 160. 40 on each side. There's 4 sides. That's 160. Slant height they labeled for us. What is it? Capital B stands for what? Area of the base. Who said base? Don't say base. Area of the base. Okay? So, how do we find the area of a square? length times width, or base times height. In this case, 40 times 40, which is 1600. Yep. Well, you're saying that the diagram kind of looks like a rectangle. Well, a square, if you hold it at that big of an angle, is going to look like a rectangle. It's just the view. If you ever, that's why I said like the regular, it's always going to be regular. So if they don't tell you, it has to be all the sides of the same length. I'm going to give you all regular polygons. So the fact that it's not labeled, we can just assume. Yeah. Yes. Okay, so the height of this pyramid would be what? Do they label it for us? No, we don't know what it is. The slant height is given to us. Slant height is here, but the height is here, and they don't tell us what that is. So how are we going to find it? Pythagorean theorem, right. So create this triangle that's in the pyramid. Height is here. 25 is the slant height. What's going to be the bottom of this triangle? 20. When it's a square, the apothem is just half the length of the side. Is that true for all polygons? No, only squares, the half the length of the side, right? So that's 20. So our Pythagorean theorem is going to be 20 squared plus h squared is 25 squared. You might recognize this as a multiple of a 3, 4, 5 triangle. This is all multiples. Remember we talked about 3, 4, 5 triangles? 3, 4, 5. If one side is 3, the other side is 4, the hypotenuse would be 5. Any multiples of that works. So 25 is 5 times 5. 20 is 5 times 4. So this one's going to be 5 times 3, which is 15. Now, if you didn't recognize that, or you don't have any idea what I'm talking about, you just do the Pythagorean theorem, and you'll get 15, I promise. Okay? So the height here is 15. Don't write too big, because there's not a lot of space here to find these things. All right, so let's do surface area. Now, okay, so 1/2 PL on a test. This is exactly what I want to see. I want to see a list. I want to see the formula you're using. And then I want to see what numbers you're plugging into that formula. So you could change this to a 0.5 if you want. You can leave it as a 1/2. P, perimeter. We already calculated that. Just pull it from your list. P is 160. Put it right in there. Slant height. What did we find for the slant height? 25. Plus capital B is area of the base, which is 1600. I want to see that. After that, you can do it all on your calculator and just give me an answer. But on a test, I want to see all those parts filled in. Okay? All right. Be careful with this formula. You cannot do it all and divide by 2 at the end. This is 1/2 PL. Order of operations says you need to do the 1/2 PL all together first, then add on the capital B. You can't do it divide by 2 at the end. Remember we talked about the formula is 1/2 PL gets you this part, plus the capital B adds on the one base area. If you do divide by 2 at the end, you're only adding half that area, and that won't get you the right answer. Okay? So we're going to do 1/2 times 60 times 25, and we get 2,000. Plus 1,600, and that's 3,600. This was feet. This is surface area, so it's square feet. Volume. BH over 3. Plug in what you know. You see how this list is all done? We don't have to think anymore. We could just plug stuff in. 1600 times H, capital H is 15. Divide by 3. 1600 times 15. Then do the whole thing, divide by 3. You get 8,000. Good. This is volume, so it's cubic feet. Okay, so I'd like you to try number 2 on your own. Make your list. Same list as this one. They're both square pyramids. P, L, capital B, capital H. This is an actual pyramid in Rome, Italy. The dimensions are on the clearer diagram there. Find the surface area and volume. It says to round your answer to the nearest square meter, but be careful. I don't want you to round until the end. Everything in your list should be more exact than that, right? There should be decimals and stuff in your list. All right, give that a try. Okay, so these should be the values in your list. From there, you're just pulling from that list and putting things into the formulas.